Okay, so topic for today. Basically, we want to continue with the composite design pattern. And the reason for doing this is because we got the most interesting pattern coming up called visitor, and which we'll do hopefully in the second half of the lecture. I'm not too sure if I can really finish the visitor lecture, but I'll point to you some further reference, and possibly we have to continue next Monday. Okay. So now for the composite design pattern, let me just review very quickly the motivating problem, and then we can try to review the first design we talked about last time on Monday, and then we'll try to talk about maybe the second design, and then eventually the composite design pattern. Again, we want to see criticism on each alternative. The motivating problem really is you want to build not necessarily just a manufacturer system, any system that's somehow kind of hierarchical. You can use a tree to really model your system, and which means you got individual components like a base cases or leaves in your tree. And also you got subsystems like internal nodes in your tree, or they're like a recursive cases. That's how you can think about. Remember we talked about state pattern. State pattern, the motivating problem would be interactive system. For composite pattern, when you got hierarchical and it can be recursively defined system. In that case, you use composite design pattern. Right? Just keep in mind the kind of problems you can solve using different design patterns. Okay, we talk about different cases over here, and that's one possible tree that you can actually develop using your composite. Okay, just keep that in mind. That's something we want to build eventually. Okay, and then for our particular purpose, we want to see how we can calculate price. Okay, for individual components. For example, let's say for this particular tree over here, let's say for example, a card costs about $100, and also a hard drive is like a 200 each, and also CD-ROM maybe 500, and also power supply maybe 200, for example, right? Excuse me. So you got prices for each individual components. You want to add them up together. So what we want to see what the total price is. We want to see how we can do it in a systematic way. We'll see that at the end for the composite pattern. Okay, we talk about also multiple inheritance. Just prepare you for the composite pattern. Okay, that's what we got. All right, I'm just gonna skip because we talked about them already on Monday. You can also refer to the recording, and I'll review the solution page at the end once we are done with covering the composite design pattern. Okay, I'll get to this at the end if I remember. All right, so this is the very first design that we talk about towards the end of Monday. Okay, and the main criticism about this particular first design, okay, let me just remind you very quickly, is about cohesion. Okay, cohesion. So the main violating principle that we have over here is called cohesion. So it violates cohesion because you can see, for example, this drive over here is a basic components. You can think about cabinets, for example, is a recursive components. Only the recursive components should have the ability to build further some other components underneath. On the other hand, if you can see over here, we got add child over here, and also we got children, right? We talk about these two attributes specifically, and also how you can draw diagrams for them. So these two are both at the level of equipments, which means these are also inherited to basic. So which means basic also got children, and also basic also got add child. In that case, you will have some very unrealistic scenario. For example, let's say over here you got card over here, which is a basic components. Also you got chassis, you also got disk over here. So it would be okay as far as compilation is concerned. If I simply say card dot add child. Over here, for example, I'd say I want to add a disk into a video card. It makes compilation sense, but it doesn't make any reality sense. So that's the flaw of the design because of the cohesion violation. Okay, again, the idea would be you shouldn't really put add child and also children into the basic cases like a video card and disk drive. Okay, that's actually the flaw of the first design that we talked about last time. Okay, any questions about this if anybody want to ask? Okay, again, I mute everybody by default since we got quite a bit of participants over here. If you really wish to speak up, please let me know from the chat. I will unmute you if you wish. Otherwise, you can just text me about the questions. Okay, I assume so far no questions about the Okay, one moment. Sorry. Somehow I got interrupted. Okay, guys, sorry. I somehow got interrupted. Okay, let me do it again. Okay, sorry about that. Let me sort it out quickly. Okay, so I think... Okay, so sorry, I was interrupted somehow by Zoom. Okay, so now you can still see my screen. I believe you can still hear me, right? Sorry about that. Okay. All right. But now, if you still got any questions, you can ask me about what I just reviewed. Okay, but when you see the recording, there was no interruption, so you don't have to worry. Okay, sorry about that again. Okay, so this is about what we want to talk about for the very first design because of a violation for cohesion. Okay, I assume there's no question about this, right? If you got questions, let me know. Now, I want to move on to the second design. And the second design may not be the ultimate one we will wish to adopt. Let's see why, okay? So now let me present to you again the second design. And now again, you want to really build the ability to really imagine how the design is going to work just based on the bound diagram, the design diagram. Okay, let's see how we can see that, okay? Okay, now first of all, you can see mostly the same between the first and second design. Let's see what the critical difference is. Now the critical difference is, it seems like the composite class over here is becoming more coded, actually more implemented, which means we're adding more features or more code into it. If you compare with the first design, in the case of composite, we only use an oval shape because it could be just simply like a very minimalistic class, maybe just empty, let's say in the first design case. But now in the second design, we said in order to satisfy cohesion, which is the flaw in the first design, we try to move add child and also children. We try to move these internal specific features into the composite. So which means in the composite class, we got children and also we got add child over here. And notice the type for the parameters. You can see for the children over here, we simply say a list of equipments. So which means underneath, for example, cabinets, you can either put another chassis or you can put another video card underneath, right? Because any of the descending classes for equipment should be okay, right? So that seems to be a valid design choice. And also, when you want to add a new child underneath a particular composite, you can say equipments as well, okay? Everything seems to be okay, right? And then one thing to notice, which is a dramatic improvement from design number one. Okay, if you try to look at that, let me just get rid of this particular panel here. Sorry, just give me one moment. Okay, good. So now I want you to look at one particular case. I'm showing you a very similar block of code in order to judge the design. Specifically, you can see we still got chassis, we got video card, and also we got disk over here. And now I want you to pay special attention to this particular line over here, right? So now you can see for this particular line, card is the context objects, right? It's of type, basically card is of type video card. And video card is directly from equipments over here, right? In the case of the first design, we said that such line over here is going to compile because the video card over here inherits from equipments where children and add child are actually declared, so it was okay to call them, right? Now, in the second design, we want to prevent such unrealistic situation. So now in this case, if we try to say context object of static type, in this case, video card, right? So now when you talk about video card, you can see only the price, the common feature among all the equipments is defined. On the other hand, we don't have the children that's defined. We don't have add child that's defined. These two features are actually defined in the composite, right? So that's the main improvement we made from the first design. So now in this case, you can see for this particular line, it's not going to compile, not compiling. Okay, the reason is add child over here is a feature applicable When I say applicable, I mean it's part of its expectation. Remember, when we review the inheritance lecture, we always talk about expectation. So now it's not only applicable, you can see for add child, and for children, only applicable for the descendant classes for composite. Applicable to descendants. Descendants of composite. Okay, it's a very quick summary of the advantages for the first design, for the second design, sorry. So the main advantage here, okay, advantage is we do have cohesion. Cohesion is satisfied. So that's a major improvement from the first design where cohesion is violated, right? Okay, now, before I ask you questions, do you have any questions over here? Anybody? If you got a question, please speak up and let me know. No questions? Okay, I do have a question for you. All right. So now, again, every time you want to judge whether a design is appropriate or not, you want to think about different design principles that we talk about. So now, to save your time, I'll give you a hint. Okay. What about single choice principle? Single choice principle. Okay, I will pause a little bit and try to see if you want to answer. Anybody want to speak up? You can send a chat message to me. Okay. Anybody? Okay. Hopefully the chat message is enabled, right? I hope. Okay. All right. So let's see. Okay, anyone want to see how the single choice principle, whether it's violated or satisfied? Is it satisfied or violated? Okay, that's the main thing we want to consider. Okay, so now I would suggest that we actually consider the following scenario before we get to an ultimate answer. Okay, so now let's say the following. Let me add a new page over here. And then let's consider a slightly more complicated scenario, right? So far, we talk about only for equipments, right? And for the equipments, we basically, let me just reproduce the hierarchy a little bit, just to, as a quick overview, so you can see what way I'm going for, okay? So we actually got equipments over here, which is deferred, under which we got as many base cases as we like. Let's say video card. Okay, that one is effective, right? Let me just put one as an example. And also under over here, we got composite. And composite itself is still deferred. And of course, under composite, we got as many recursive cases as we might declare for our particular case, right? Let's say we simply got, let's say, bus or chassis, or also for cabinets, right? Let me just put bus for now. Okay, that's basically what we talk about. And also for composite, we actually got children over here, and also we got add child. And more precisely, children is going to be a list of equipments, and also add child is going to be adding a C of type equipments. And let me just highlight what's important over here. You can see equipments over here. Sorry. You can see the equipments over here is referring to the equipments over here, right? And also the equipments over here is also referring to the equipments over here, right? Just to be as general as possible. Okay, so now I wonder if this is already a little bit of hints for you already, right? So now, do you see any potential violation for single choice principle? Let me write it down again, right? Single choice principle. And of course, in order for you to know why single choice principle might be violated, let's review what single choice principle is. Okay, it would be a violation of that if somehow, if you have a change, it will take multiple places to fix them. Multiple places to undergo the changes, right? Doesn't matter what kind of change it is. Maybe to add a new class, maybe to consider a different application, or maybe consider different things, right? Just any change that can be to your design, right? So now we want to know why or why not there would be a violation for single choice principle having this particular second design. And for the second design, you have a very standalone composite class. Okay, so far that's a hint for you. Okay, right. It seems like no one got a question over here, or okay, anybody? Okay. I guess what we can do now is to actually think about another application. Okay. Sorry, I just want to make sure you can still send text messages, right, to me. I just want to make sure, otherwise maybe I'm not seeing it. Okay. Can any one of you send a text message to me, just in case I cannot see it? Do we have text message over here? Let's see this. Okay. Show the chat. Oh, that's good. That's good. Okay, very good. Okay, thank you. That's good enough. Okay, good. Could you clarify a bit? Okay, I got some message from Gavin. Okay, I'll pause a little bit. Maybe I'm going a little bit too fast. So Gavin, which part do you want me to clarify? You want to be a little bit more clear? Which part? Could you clarify a bit the previous example? When you say the previous example, do you mean the second design or the first design? Okay, the second design. Okay, so okay, let me try to put my question a little bit more carefully. Okay, because that's really important to understand why the second design is actually not as good. Okay. Oh, this one here, sure. So Galvin's question was like this. Okay. Basically, you can see for the second design, when you I'm talking about this line particularly, this one. Okay, this line specifically. This line, if you try to apply the same line for the first design, this line will compile positive, right? In the previous one, right? We said this line over here will be compiling, which is bad, because in that case, you would allow a disk drive to be inserted into a video card. That's completely unrealistic. That's a flaw for the first design. In the second design, this line here, the same line, is actually not going to compile, which will signal some proper error messages, right? Because over here, if you try to see the card over here, whether or not this particular feature or method call should compile depends on the static type for the context objects. The context object here, CRD, was declared to be video card. So now all we're gonna ask will be whether video card itself declares any feature called addChild. In this case, no, because video card only inherits from equipment class, and we have already moved out the children and also addChild methods or features into the composite only. So only the composite descendants can actually call these two features, right? So you're saying that, good, okay. Another one of you actually said the second design can actually say, okay, just clarify, right? Good. So Kevin is now good. Not Kevin, Gavin. So now another of you was saying that if you have, let's say, cabinets, let's say if I simply say cabinet, let me use a different color. If I say C of type cabinets, and then I say C dot add child, for example, I want to add maybe the chassis and also the video card into the cabinets, right? Realistically, this makes sense. I can put whatever thing that's whatever hardware into a cabinet, provided that it's actually have enough space. Let's assume we have enough space. So now in that case, I can say C dot add child, the chassis, and also I can see cabinets dot add child over here, and then I can say maybe the video card. So this particular line here will compile. Okay, it's not a problem for the same reason as before. And also, this also makes sense because, of course, you can put anything into the cabinets, provided that you have enough space in the cabinets. Okay, hopefully that answers your question. Okay, we got another question here. Let me see. With regard to single choice principle. Okay, let me try to see. Okay, so now if I understand you correctly, you're basically trying to explain to me why single choice principle might be violated, right? So what you're trying to say is, if I try to, let's say, add a new class over here for the composite, right? For example, it could be, let me just say maybe class C. Okay, it's just another composite components over here. I'm just add so the purple one is basically the new composite class I'm trying to add. Would this actually violate single choice principle? In this case, maybe not, because the new composite class, the purple one, is still going to inherit the children and the same block of code for add child. In that case, we're just reusing the code. What if I want to redefine the way I add the children? For example, rather than adding to the end of the list, I want to add maybe to the front of the list. In that case, the only place I have to change would be to add a child over here, right? So for example, if we want to change the new child to, let's say, the front of the list. Let's say this is a change we would like to adopt. In that case, how many places do I need to go in order to change this? The answer would be only this single add child feature over here, because it's simply inherited verbatim to every descendant class over here. So single choice principle would not be violated because of this reason. Okay, hopefully that will clarify your confusion. Okay, so now, again, we want to know why the second design over here will actually violate the single choice principle. Let me tell you what the answer is, okay? Just give you more hints, basically, okay? Again, we want to see how exactly we have to, for a particular change for the design, we have to go to multiple places to actually change it, to make the change, okay? Currently, we are basically talking about just equipments over here. That's just one application we're dealing with. But maybe in your particular application, you may have to deal with different applications. Well, what do I mean? Let's say this. Let's say in the same projects, let me use maybe a different color. Let's say pink over here. Let's say we want to deal with just another cluster over here called furniture, where we got chairs, we got desks, and also we got bookshelf, or maybe we got also got shelf, for example, right? So now, let's say in the same projects, we would like to handle two applications. We want to handle both equipments and also for furniture, let's say. And now, how do we handle this? According to the second design, right? The second design is not too bad, but when things grows, you actually have to duplicate some block of code if they have to be somehow used in the same in a similar manner, which is not good. Every time you got duplicate, it's not good. Let's say this. If I got my new furniture cluster or package, so now at the top, I'm gonna say basically furniture, under which, let me say the base case would be, let's say, a chair, right? You cannot really insert anything inside a chair, so chair should be a base case. Okay, over here. And then what about the composite? Now in this case, what you will do is you will still following the second design faithfully. We should have another composite class over here. So what I will do is I'm going to put composite here, and then composite here remain to be deferred over here, and then under which we can have as many we can have as many composite cases as we like. Let's say I'll just put shelf. Okay. Okay. Oh, sorry. That should be effective. Or it could be another, let's say, drawer. So these are the two cases where these are the two furnitures, two kinds of furniture. You can put more things into it. Okay. So now, let's see this. A little bit more details. According to the second design, we should really declare children and also add child, and we have to figure out a type for the child, right? So now in this case, what we should do is we should say children over here, children, and then also we need to say add child. So now what should be the type for each one of them? So now the children over here should be a list of, over here, it should be corresponding to whatever application that we are talking about, which will be furniture, agree? So it's opposed to equipments, right? Hopefully you agree. Let me put it down. So what I should put is, I'll just put F for furniture. And also add child is now going to take C of type furniture. I'll just say F for short. Okay? So now basically we can see that furniture over here is now going to be referred to in both over here and also over here, right? So now here's the question. Hopefully you already see why single choice principle is now violated, right? Hopefully you can really see. So let me just summarize that, okay? The reason that single choice principle is really violated goes like this. You can see the children over here, the code, especially for add child, and also for the add child over here. Even though they are storing different types over here, equipment versus furniture over here, even though their elements are different types, but the way you try to insert the child into the list will be the same. So there are duplicates over here. For example, let's say if currently we are simply inserting to the front of the list, let's say. So for this particular add child, you simply add a new equipment to the front of the list. And also for this particular add child, you're duplicating it to say you should also insert the new furniture to the front of the list, let's say. So now what will be the change? So now let's say the change would be change add child over here, let's say, for example, such that inserted to the end of the list. Let's say you would like to do this kind of global change. Maybe you actually have to, for whatever reason, let's say. In that case, how many places do I need to change this policy from inserting to the front into inserting to the end, right? Apparently 2 places over here, right? You can see in that case, I have to change place number 1. I have to change the add child over here. And place number 2, let me use a different color. Place number 1, I should really change over here for the add child. And also place number 2, I should also change the add child over here for inserting to the end. Okay, so that's violating single choice principle because you have to change multiple places. Okay, any questions? So far what I have covered was like this. I talked about the second design, which does improve the cohesion issue. That's a flaw in the first design. However, the second design also suffered from single choice principle violation, and I just explained to you how it is violated. Okay. Any questions for you guys? Everybody is okay? Okay. So now the next question is, if in the second design, even though we got cohesion satisfied but single choice principle violated, how can we resolve this? Okay. The way to resolve this is we would like to see if it is possible to actually factor out the common code over here. May not be just add child, can be other code depending on how complex your application is, at least for the add child. And also this part over here for the add child. We want to factor them out into a single place, maybe a single class, and then you put the add child over there. And let both composite over there to reuse from there. Okay, that's kind of the idea abstractly. And now this will really move us to the actual composite design, right? You can see we're really trying to show you the intermediate design as we go through. Okay, so now let me go through the second design. The third design. So this will be the composite design pattern. Okay, let's go over that very quickly. Okay, you will see over there you actually got multiple inheritance, which is why we actually talked about it last time. Okay, let's see this. Again, at the top, you got equipments over here. Okay, deferred. And also you got base cases. Okay, and then you also got another category of equipments, which is composite equipments, under which you got cabinets, chassis, and also bus, right? And you can notice that children is actually only belong to composite equipments, first of all, right? But now in the third design, the actual composite pattern, you can see we no longer put, as in the second design, we put add child and children both in the same composite class, but we no longer have to. What we do is, we'll simply say we got a standalone class over here. Okay, it's really important to see why we are doing this. So now let's see this. We got composite over here, and notice that it is generic. Okay, you can see it is generic, simply of type T, which means whoever clients is going to use this particular generic class, they have to instantiate with what T is. Okay, we'll see example in just a moment. Okay, we can also use our equipment and furniture example. So now we got children over here, and also we got add child over here. You can see now the type for each child over there is simply T. So T is really depends on what T here will be instantiated into. Remember the exercise we did before the reading week about how you can instantiate generics. And also the T over here for the new child will also depend on what T is over here, right? So now I can easily say I can either instantiate T over here maybe to be equipments. In that case, this will be E, equipments, and also equipments for the children, right? Alternatively, I can do another one with the same code. I can say maybe I will instantiate that into furniture. In that case, we will instantiate accordingly furniture over here and also furniture over here, right? Okay, hopefully you can see what's going on over here, right? And then we're gonna see exactly how this can be instantiated at the runtime. Okay, we'll see that. Okay, and then, yep, actually that's about the composite. So the most important two arrows you have to see in the composite design pattern, which is common confusion, is like this. First of all, in the composite equipments over here, you do have children. And this children over here is inherited from the children over here. You can see one more details to actually make sure you can follow. You can see the children at the composite generic class level, the type is simply just T over here. However, when you actually talk about the composite equipments for this particular equipment's application, right? In that case, you can imagine that you would have said something like this. You would say class composite equipments over here. You would say inherits, okay, just part of how you would declare the class. You would say inherits composite. And then here, rather than T, you're going to instantiate it into equipments. So this is why at this level over here, you do have some client-supply relationship over here to say children, which is of type list of ... which is pointing to equipment. It's a minor detail that you want to pay attention to. So that will be the very first arrow you have to pay attention to for composite pattern. The second arrow is here to say composite equipment actually inherits from this standalone class called composite. So these are the two main architecture relations that you want to pay attention to. Okay, let me pause a little bit and to see if you got any questions, please. Okay, any questions for anybody? Everybody's okay? Okay, we do have some questions here. Let me take a look. Could we instead create new classes, computer furniture that are clients of the equipment class over here? Then there will only be a single composite class. And okay, basically, okay, the question from Manage is really about how you can actually got multiple instantiations of the composite design pattern. Okay, let me hold on this question a little bit. I will show that in the next slides. Okay, I got another question here, which simply just say hi. Okay, I guess I just say hi. All right. Okay, we got another question here. Is furniture and equipment class use one composite equipment? Yes, correct. That's exactly true. So both of you guys' questions are the same. You're basically just asking how we can use. How about this? Let me phrase it this way. If I claim this composite class over here to be reusable, but how exactly do you reuse it? At least you should reuse it in more than one places, right? Okay, let's see exactly how that's going to happen. That's exactly in the last slide, in the next slide. Okay, one more thing I want to say. Okay, that will be a self-exercise for you. Okay, I want you to think about. Okay, again, the line that really bothers us back in design number 1 was that this particular line compiles in design number 1, but in the improvement that we made in design number 2, make sure this line will no longer compile, which is good, right? Now, exercise for you. And then try to give your answer in a justifiable way, okay, in the way that I try to explain why design number 2, this particular line wouldn't compile, right? Try to use a similar reasoning, okay? So now, should this compile? Okay, that will be exercise for you. Okay, so now let me try to, does composite equipment also inherit equipment? Indeed. So this will be responding to John's question over here. So now I said this is the client-supplier relation you should really pay attention to. And also this is the inheritance you want to pay attention to. Maybe I should say there are 3 things. Also, you can see there's another inheritance over here. You can see that one is also inheritance relationship. That's why we got multiple inheritance. Okay, let me put it here. So these 2 lines are multiple inheritance. Okay, I know the diagram is getting a little bit messy, but before I get to the multiple instantiation, let me show you something here. Okay, I would suggest when you actually study for this particular lecture, okay, just go to my lectures page. I'll show you which one you can download, right? I already made the design diagram, the clean version over there. So go towards the end, and then you will see the bond diagram over here. For example, the bond diagram for composite design patterns. You get a clean version. I would suggest maybe print it out and try to recreate the story I just told you, okay, just about how you can study the design pattern over here. Okay, I'll leave that to you. All right. So now back to you guys' question about how we can instantiate the composite patterns multiple times by reusing the composite class over here. Okay, there you go. Okay, again, this page over here is really, again, exactly what I'm going to show. Why composite should be a separate class. Okay, the answer would be, okay, when we instantiate the composite pattern multiple times, okay, in this case, the composite class over here, the composite class can be reused. Okay, can be reused. Okay, anyway, so that's an answer to that. Let's see exactly how we can instantiate that multiple times. Okay, so now let's take a look at this particular diagram here, right? Now, let's see. I'll try to enlarge that when necessary. Okay, let's take a look. First of all, let's take a look at the standalone class that we really like, which is the composite. Right? Notice that it's actually generic. Notice that I just changed from T to G just for fun. Doesn't really matter what generic parameter you choose, as long as it does not clash with any of the non-existing classes, then you're fine, right? So you got G here and also G here. I also put array. You know, doesn't matter. Just as a linear collection. So we got composite here. Okay. So now you can see basically. Let me make some notes for you. So this class over here is generic and maybe instantiated for its generic type G over here. So now you can see this G here may be instantiated for whatever class name you like. It could be furniture, it can be equipment. We'll see. Okay, and then and also reused for its code. And the code that we can reuse will be, for example, add child. For example, right? Let's say currently we always add a child to the end of the list, right? Let's take a look at the 2 possible instantiation. Okay, let me just give you the big picture and now I'll zoom in to each one of them. The first one is called equipments over here, right? You can think about this is instantiation number 1 of the composite pattern. And another one is called furniture, right? So now you can think about this one here is instantiation number 2. instantiation number 2 over here. Okay, so now let's see quickly. Okay, for each of the application over here, let's see the 3 arrows that we really want, we really care. Okay, number 1, you can see in both cases over here, we do have the client-supplier relation over here. We do have the client-supplier relation over here. You can see, okay, a little bit more detail here. When you say dot dot over here, the dot dot here is referring to equipments. Okay, and the dot dot over here is referring to furniture. Okay, first of all, notice the difference. So the only difference between these 2 applications are the member type. One is equipments, the other one is furniture. But the control structure for the code can be reused from Composite. Okay. Okay, let's go a little bit further. And then the second arrow that we want to see, you can see both of them inherits from their corresponding root hierarchy, right? You can see here, composite equipments inherits from equipments. That's the root of the hierarchy in that particular cluster. And also you can see composite furniture here also inherits from furniture in its own cluster, right? So the second arrow. Now the third arrow over here is going to show why single choice principle can be satisfied. Because now you can see that this guy here, right? You can see composite equipment also inherits from composite. And also you can see composite furniture also inherits from composite. Okay, let me just give you a little bit more details before I can take your question. But I hope that's clear enough for you. How do you actually make such instantiations programmatically? It's actually quite easy. Okay, let's see. For this particular guy here, what you will have to say is, you can say class composite equipments, and you would say inherits over here, let's say composite. Now we want to instantiate the G over here into the top class in that particular root inheritance hierarchy. So we will say equipments. Okay, that's one case, right? That's one instantiation. And what about another one? Another inheritance hierarchy will be the composite, let me use maybe purple. Let's say composite furniture over here. So now how do we declare this class in a similar way, right? So now what we would say is, you can say class, and then you would say composite furniture. And now you would say inherits from the same class that we want to reuse its code, but now we have to make sure we instantiate its member type accordingly, right? In a different way. So now I would say composite, and then I don't say equipments anymore, right? That'll be a mistake. So now I should really refer to the top class in the root of the hierarchy, right? So now I would say furniture. All right, so now one more colorful highlight, and then I'll take your questions. So now you can see the equipments over here is referring to equipments over here, and also the furniture over here is referring to the furniture over here. Okay, I'll pause now and then take your questions. Christine, so does the composite pattern use the same idea as templating? I would say it's not quite. I think the main essence about the composite design pattern goes like this. Okay, I think what Christine may be confused about is when we talk about template design pattern back in the state pattern. Let me just try to summarize quickly the 2 patterns quickly. Okay, but they are very different, I can tell you. In the case of the composite design pattern over here, right? So the main thing is really about, you have basically the root of your inheritance hierarchy for a particular application. And then under which you got base cases, and also you got recursive cases. In the case of the recursive cases, you got these 3 arrows over here you have to watch out for. One is for client supplier, and the other one is going to exploit multiple inheritance. And for code reuse, we also got a standalone composite class over here. So that's the quick summary for the composite design pattern. But the template design pattern, okay, let me just say very quickly. So when you talk about the template design pattern, let me try to, you can also refer to the example in your state design pattern, like execute states. Let me just give a little bit more abstract summary of that. For example, let's say we have a class called A over here, which is maybe deferred. Doesn't matter. It does not have to be deferred, but let's make it deferred for now. And then also we got another class over here called, let's say B, and also we got another class over here called C. Okay. And then let's say in class A here, let's say we got a let's get an effective feature implemented. Okay, so this is effective, which means it's also implemented. And then let's say we got another 2 features over here. Let's say we got maybe G1 and also G2. Okay, let's say they're both deferred. Okay, so now let me say a little bit more about the template design pattern. Okay, so now let's say in this F over here, let me make it very simplified. Let's say for the feature F over here that's defined in A, it simply say do, I would say just do G1 first of all, followed by G2. So you can think about over here, it's more like a pattern for composing G1 and G2, right? You want to say do G1 first, followed by G2. Think about G1 is like a phase 1, and G2 is like a phase 2. Okay, let me say that here. So this is more like a pattern. Pattern for composing the execution of G1 and G2. And if you look back to your state design pattern example, you actually see the way we compose, maybe read, display, process, etc. We're doing a similar way, just more sophisticated. Okay, so now let's go a little bit further here. Because now you can see G1 and G2. So these 2 features are simply deferred at the level of A. So now let's say for B and C, they are simply descendant classes. If we want to really be able to create instances of B or create instances of C at a runtime, they must be completely implemented, which means G1 and G2 over here, G1 and G2 over here, we cannot leave them as unimplemented, right? They must be implemented for sure. So now it'll be plus and plus and plus and then plus over here, right? So now if you see that, you can think about this particular one is version B, which means when you call G1, when you call, for example, let's say this. Okay, let me just try to, I'm just trying to review very quickly about the template design pattern. And let me just say one more thing here. And also G1, G2 here is so-called version C. Okay, version B and version C. Okay, and then how do we actually compose them together, right? Let me just do one more thing here. If I declare, let's say, objects over here of type A, okay, and then if I say creates B obj dot make, assuming that the make feature is actually defined, right? Let's assume that. And now if I say obj dot f, okay, versus if I say creates over here, and then I say C here, and then I say obj dot make, and then I would say obj dot f. So now you can see that here obj dot f, obj dot f, right? So they are actually the same line, right? You can see obj the same, f and f over here the same. However, will their behavior the same at the runtime? It turns out the template design pattern allows you to have different behavior because of dynamic binding, depending on what the dynamic type is. Okay, I'll summarize very quickly. In this particular line, the dynamic type is simply just B, right? So that means when you try to call execute the feature F, you will still call this particular version over here, but when you call G1, it's going to call the G1 over here. And when you call G2, it's going to call the G2 over here. So overall, the pattern for composing G1 and G2 is the same. G1 followed by G2. Okay, good. Let me just do one more. Okay, and then if I try to go for this particular one, you can see dynamic type will now be C. And now obj dynamic type will just be C. we are still calling this particular pattern over here the same pattern, G1 followed by G2. But now, because dynamic binding, dynamic type C, so now I'm going to call G1 followed by G2. Okay, it's a very quick summary for the template design pattern. Okay, no worries. Okay, if we want to all composite design pattern instantiate and share some code, where could we put that code? I would say one example would be, the question was, you want to be a little bit more creative, of course. The composite design pattern itself tells us this is the place to put some common code about composite, okay? Of course, when you actually have your own design over here, you can try to extend the composite design pattern. I'll just give you a little bit idea over here. For example, you might say, I decided maybe for every composite equipment class, I also want to have another class here called utility. Utility here, which might be, for example, okay, let me just draw a little bit better for you. Okay. Again, when you actually want to do design, it's open-ended, you want to be creative. So I'll just give you some idea, some guidance. In this case, let's say I have just another class that stands alone. Maybe I call it utilities, UTIL, let's say of type T. Again, it's generic, which means I can say composite equipment also inherits from utility. Also, composite furniture also inherits from utility, right? Of course, the T might be instantiated into equipment versus furniture in a similar manner. So now, this will be maybe answering your question. So now, under utility, you might put some different stuff. Maybe, for example, you want to put a sort command over here. But now, you can either sort equipment or you may want to sort furniture. Well, it depends, right? So hopefully that's answering your question. Okay. All right, so that's about the composite design pattern, and also we talk about multiple instantiations for the composite design pattern. Okay, any questions? Everybody is okay? Okay, hopefully. Again, if you really got a question, please just send to the chat message. I can see that right away from my monitor. All right, so now what I would like to do now is to go over a little bit of the code, and then I need to trace very quickly how the composite pattern works, which could be a little bit tedious. I'll try to keep that as brief as possible. At least you will get an idea. And then we can talk about the next design pattern. Okay, so now let me go back to the slides to show you very quickly. Okay, we talk about the flaw for the first design. Well, everything's we have covered already. So you can definitely go over the recording for more detailed explanation. Okay. Okay, I got another question here. So, okay, let me read the questions out, okay, before I try to go further for the slides. Okay, so we got, so the composite and util examples that you talk about, which is here, right? Okay, let me just go back to the iPad. So the question was really about introduction of this particular utility class, okay? And the question was, the reason you're using util example was because just a mixture of both template design pattern and the composite design pattern. Is that the case? No. Okay. So again, when Christine actually asked me about the question, what's the difference between the template versus composite? I was trying to explain. They are very different design patterns. They are not really similar even, right? So that's why I was trying to explain. This is how the template design pattern works. You can refer to the state design pattern to review it. However, when we talk about the composite design pattern over here, it doesn't work in any way that's similar to the template design pattern, right? So what I'm trying to say is you can try to create as many classes as you like that serve in a similar purpose that's like a composite. So you can try to use multiple inheritance. Over here you can see for a single composite equipment class, you can inherit from utility, you can inherit from also composite, you can also inherit from equipments, right? That's something you cannot really do in Java, because Java only allows multiple implementation from multiple interfaces. Would it be better to put the util class inside composite such that composite is a client of util? I would say it really depends on your particular application. So in some way, I was just trying to make up the example on my on the fly. So I would say don't really worry too much about this particular example over here. I'm just trying to say you might design some separate class over here such that you can still make use of multiple inheritance from different one. But my point is, whatever class you decide to actually make over here, it should be for a different purpose from composite for cohesion reason. Okay. Would a mixture of both the template and composite design patterns ever be useful? Can that even be implemented? I imagine you can do it. It's implementable. Okay. Okay, sure. Okay, that's composite. So that's composite alone. Okay, and this is template design pattern alone. Your question was, can we somehow combine them? Right? I can show you how you can combine them abstractly. Whether it will be useful or not depends on whether you got an application for that. I don't have any concrete example in my mind for now, but I can show you quickly if you really want to combine them very quickly. I think that's good. Good question. Okay, let me just make sure I answer all the questions before I move on. Okay, I think that's important. Okay, basically the question was really about mixing or combining. Mixing composite and also template. Okay, so these are so far two independent patterns that we talk about, but since they both try to use OO, so maybe you can let it work together, possibly. Let's see how we can do it. I'll just give you a little bit idea. Okay, let's say this. So let's say this is class 1. Okay, let's say this. I'll just say A here. Okay, I'll just show you the structure, right? So forgive me if I just use some symbolic class names over here. Under A, we simply got maybe base case 1. And also over here, we got composite for A, right? And then here we got composite 1, and also we got composite 2. And also over here, let's say we got, let's say D. Okay, and then we got base case 2, and then under that we actually got composite for D, and then under that we got composite 3 and composite 4. Right, just focus on the structure. The names are not really important. I just want to show you how you may combine them together. And now remember we also got things like let me just draw them quickly, right? Also, you got a client supplier over here, right? And also, you got the client supplier over here. Okay, I'll just omit the label just for now. Okay, you should really put in the label later. And also, we got another client supplier relations. Okay, so now you basically got some common ancestor class over here. Oh, sorry. Okay, if you don't mind, I'm going to be a little bit messy here. So, like this, right? And then let's say this guy here. So this will be the composite. And then, so this will be deferred, this will be deferred, and everything else will just be effective, right? So far, I'm only talking about composite so far. Let's see how we may actually combine or mixing in template design pattern. Again, I don't have a concrete example in my mind, but it could be useful theoretically, right? But let's see how we can do that, right? Again, you can see this is in a single cluster. You can think about this guy here is in cluster number 1. And this another group of classes, they are in cluster number 2. Okay, like that. Okay, so now let's see how we can actually incorporate the template design pattern. We can definitely do it. You can think about the way I'm going to do it is by thinking about composite over here is more or less like the A over here. Okay, you can actually, when you study the notes, you can think about the way you're going to treat it is like an A over here at the top is like the composite class over here. Or alternatively, think about the composite here is a little bit like the state class that we talk about in the state design pattern, right? So now, one way to do it is to think in this way. So maybe you have let's say execute, for example, for whatever reason. You want to have an execute feature in your composite, right? And that feature there is simply implemented. Okay? And then you may have other features like a F1, F2, for example, let's say, and also even F3. Deferred, deferred, and deferred. Okay? And for execute over here, you can think about it's implemented. So the do and end over here, I am not going to specify a particular order, but somehow you're going to put F1, F2, and F3. You're going to refer to them in any particular control structure. You might even say, you can say do F1, and then you can say loop, and then you say F2 followed by F3, and then end, right? You can do whatever control structure you like for this particular execute bucket, anything. But now you can see F1, F2, and F3 over here, they're all deferred, right? At this level here. They're all deferred. So now we are really relying on the F1, F2, and F3. They are actually defined in the individual classes, which means you're going to make sure, for example, F1, F2, oh, sorry, not here, right? Only the composite one, beg your pardon. So now you can see F1, F2, and F3, that we inherited to, for example, F1, F2, F3, right? That'll be one version over here. Also F1, F2, and also F3 over here. And also F1, F2, and also F3. And F1, F2, and also F3. Okay, one more note to make. One more note. When you actually do this particular design, so that means somehow F1, let me see this. When you talk about this particular cluster over here, so when you talk about F1, F2, F3, you will know that these versions will somehow work according to A, for example, equipments. And also similarly, if you try to do, let's say this, let's say F1, F2, F3 for this particular cluster over here. So here F1, F2, F3, F1, F2, F3, they will have to work inconsistent with maybe the class B over here, for example, furniture. Okay, it's a very quick sketch about how you may combine the two design patterns together in a symbolic way. But you can actually think about your own example, maybe for your own application. You can definitely try to mix design patterns together if that makes sense to you. Okay, let's see this. I mean, see another question from Atto. So is composite design pattern only used when your classes have both a base case and a recursive case? I would say that's quite accurate, yes. When your particular application has a notion between subsystems and also base cases for the system, yes, like a tree. In that case, you use a composite, right? Elvis, let's see over here. For Elvis, if composite furniture don't need the functionality from util, why don't we don't need to inherit it? Yes. So when I talk about utility over here, I was just trying to make one example over here to say, assuming that maybe for every composite instantiation, you may have some utility that you want to support. You just put it there, right? So again, it depends on what you need for your example. I'm just trying to sketch the possibility for your design. And when you make your own design, either for your projects or beyond this course, try to be creative. Okay, hopefully I answered all the questions. Okay, good. So now, let's go on a little bit. I know I got about 15 minutes or so. I might just run slightly over time, but I'll try to control my time. No later than 2:30, I promise. No later than that. Okay, let me go back to my slides over here. Okay, let me just go over very quickly with you the code. So we got the deferred class code equipments, and also we got name and price. So we're gonna see exactly, so you can see the price over here. Price is now going to be having two possible versions. Either we're talking about the price for base cases, maybe the price for a single video card, or maybe the price for a single disk drive. Versus maybe when you say, if I got a very huge cabinet, what should be its price? So now we are talking about the price for the composite elements. In order to figure out what's the price for a single cabinets, we want to aggregate up all the elements that's within that particular cabinets, or we're going to sum up all the value for its subtree. Okay, I'm being a little bit vague, but we'll see. Okay, I got another question over here. Let me, George. Okay, the difference between state design pattern and composite design pattern is multiple inheritance. I would say there's one difference over there, yes, because yeah, I wouldn't have to go back. So when you do the state design pattern, you don't need really the multiple inheritance. Whereas for the composite, yes, you do need multiple inheritance. But I would say that's only the structural difference you're talking about. Maybe try to focus more on what kind of problem you can solve by each one of them. Okay, but what George said was right. Yes, one uses multiple inheritance, the other one doesn't use it. But as I said, you can try to incorporate one to another if you think that makes sense for your particular application, right? Okay, we got deferred class equipments over here, and then we got price either for base case or you got it for recursive case. Okay, so now for base case, for example, you might say, I'm just going to assign the price for the card to be, for example, 200, right? Okay, that's easy to see. And now we want to see how do we define a price for composite equipments. Let's say we got, let's do the composite class first. You can see it's deferred, it's generic. We got children, we got add over here. Okay, polymorphism over here simply means, so now the C here is of type T, which means whatever I can add into the children list will be a descendant class of the list. For example, over here, let me just go very quickly. Okay, let's say over here, you can see we're talking about add child over here, right? So now at this level here, add child has been instantiated into, over here, C should be of type equipments. So that means we can add any objects that's a descendant class of the equipments, which includes disk drive, video card, cabinets, chassis, and also bus, right? Any descendant class of equipments can be the child classes. Okay, let me go a little bit further. Okay, polymorphism here, you can think a little bit more. Why? It will satisfy multiple shapes of the runtime objects. Okay, now exercise for you. If you want to do more exercise before you graduate from this course, it's up to you, but optional. You can check your answer with me during the office hour if you wish. How do you make the composite class iterable? Okay, question. I'll leave that to you. Should be easy, I hope. And then let's say we got the composite equipments. So now it's going to inherit from both equipment and composite, right? Remember the two arrows that we talked about, right? It's going to inherit from both equipment and also from the composite, right? The two inheritance arrow. And then we also got price over here, right? In the case of like a video card, like a base cases, we simply assign a concrete price to that. But now let's say the price is simply just for cabinets, for example. Now, how are we supposed to actually write this particular price definition? For example, the composite equipment that we're talking about may be, let's say, for example, it may be a cabinets. The cabinet itself might contain, let's say, one video card and two power supply, for example, what? One video card and also two power supply. What would be the price for this particular cabinets? That's a question. Can we just assign a fixed price to it? First of all, can we do it? The answer is no, because the structure, the tree structure for this particular cabinet might vary from runtime to runtime. Maybe another structure for the cabinets could be maybe one video card and only one power supply, for example, right? Or it could be maybe the cabinet itself contains a sub-cabinets. So the structure of the cabinet is now fixed at the compilation time. It can vary at the runtime. There's simply unlimited number of combinations you can have, right? So now, how can we have a general solution to figure out the price for a given cabinet, which can be arbitrarily structured? That's a question, right? The answer is you can as easy as use a loop to go over all the children, in the cabinets. Remember, cabinets should inherit from composite, which has the children feature, right? And now, why don't we simply go over all the children for this particular composite equipment, which could be cabinets. And then we're going to say cursor, the item over here will be of type equipments, and then we want to figure out its price. I'll get to this tracing here a little bit later, okay? But now I want to pause a little bit here. I want you to look at this fragment of code, this loop over here. Any question about this, first of all? Okay, I'm going to take question if you have, before I highlight something to you. Okay, since I did no question up to now, maybe that's not too bad. I just want to highlight something if you allow me. Okay, so now let's say this. First of all, you can see the price over here is the price for basic components. And the price over here is for the composite components. And now when you see the iPad notes, you can see I try to duplicate, mirror the structure, right? You can see for the composite, you actually got multiple inheritance. And for base case, you only got a single inheritance, right? Just notice the difference, right? So now I want you to look at, for the case of composite equipments, now if I get a cross loop over here, I'm going to trace together with you about the code, but before I do that, can we just have a very quick check for you, okay? So now, if I go across the children, and the children actually comes from, okay, notice that, how do I figure out, here's my question. Cursor, the item over here, what's the static type for this particular expression? Anybody? Anybody want to tell me your answer by typing? Anybody? What should be the static type for cursor, the item over here? Equipments. Good. Equipments. Pretty good. That's nice. Very good. Equipments. Okay, very good. I'm glad that nobody said it should be cart. Okay, but just in case, for those of you who may not be following, let me just tell you very quickly why that should be equipments. Thank you. So now let's see this. Here, you can see that for this particular class called composite equipments, right? We say it should be inheriting from composite, and then we get instantiating whatever generic parameter it is by equipments. Let's see that. So now this is our composite class that we're trying to inherit from, composite, right? And then we're instantiating by equipments. So that means T here should be equipments. Accordingly, we also know that the children over here will be instantiated into linked list of equipments. So that means every element in the list should be of static type equipments. So now, when you actually say cursor, the item over here, static type should be equipments, right? For those of you who responded, that's correct. And then, if I call the price over here, how can dynamic binding help us in this particular case, right? So now, apparently there are two versions of the price feature. Version number one, it can be simply the price, for example, 200 for basic components. For version number two, it could be referring to the price over here for composite equipments, in which case you have to go over a loop to figure out all the components and add them up together. We got two versions. So now, dynamic binding is actually going to help us to execute this particular loop and then figure out the correct answer. Okay? Of course, we need to convince you by tracing something quickly for you. Okay? So now I would suggest that I think that's the only thing that's left for the composite pattern. So I don't think I can really get to the visitor pattern today. Can I just take the next 5 to 10 minutes to really trace the code together with you? So we got a very good closure on this particular composite pattern. And then next Monday, we'll do the visitor pattern. Hopefully we can finish that in one lecture. Okay. Before I'm going to make the slides available to you, but let me just point out one more thing to you before I start tracing the composite. Okay, let's do that properly. I would suggest for those of you who want to do a little bit more programming design pattern exercise, I would suggest the following. If you can simply go to, again, my lectures page, you will see over here under tutorials, so there is one tutorial there. It's called the Composite and Visitor Design Patterns. I would suggest you can start going over this particular tutorial. Is very self-contained. It shows you from the beginning until the end to build some working examples, some simple ones, to see how a composite and also visitor design pattern work. But I would say if you can finish this by Monday, you can help also the lecture on Monday when we talk about visitor. Okay, if you click on that, it's going to tell you the composite and design patterns. Okay, not very long, maybe just a few hours if you can spare the time. It's up to you. I would suggest you do that by Monday. Okay, let me go back here. What I would like to do now is to trace some code together with you. Before I go into details, right? Hopefully I can finish this within 10 minutes, okay? And then we can finish the lecture for today. Okay, so far I got about 40 people right now online. That's pretty good, okay? A little bit less than Monday, for which we got about 53. But anyway, let me just go back to the slides over here for the composite, okay? Let me just go over with you the test case in a very quickly, just line by line, and then I'll trace it line by line. We declare equipments over here, and also we declare cabinets, we declare chassis, right, etc. Right? We got different types over here, and then we also got bus. And so now let's try to create each individual actually components over here. I'll just go over the general structure for the code, and then I'll trace it together with you in detail. Let's say we create cart, this drive, and also the bus, the chassis, and also the cabinets, right? Create each one of them. Up to now, they have no connection with each other whatsoever. And then we're going to try to connect them by using the add child or add. Let's say add rather than add child, but they have a similar purpose. I can say try to add a cart into a bus, try to add a bus into the chassis. I can add a drive into the chassis, the same chassis. And also I can add a chassis into cabinets, etc. And now, finally, I want to know what's the total worth of the cabinets, which you can think about as the top level of the tree. What should be its price? And it should be 700, because if it boils down into adding up the cart and the disk drive, which would be 200 plus 500, right? That's an overall quick picture, right? Any questions about the structure for this code before I dive into tracing them? Okay, everybody okay? If you don't mind, I'm going to blow my nose quickly. All right. So now let's take a look on the code itself. After this, we're done. Okay. So another question is, can we add recursively? I think the way I show you to add is by doing that manually. Yes, but I would say that one's a little bit more advanced. So you can think about the sequence of additions. The sequence of invocations of add. The purpose of that will be to build a tree. Of course, you might build a tree either iteratively, manually, or recursively. Yes, to Minesh's question, you may build a tree recursively. In that case, I'll leave that to you. Okay, so now let me go back to iPad over here, and now let's go over the tracing very quickly, right? But I try not to be skipping too many details. Okay, the same block of code, the same. And notice that we also got either version 1 of the price over here, or we got version 2 of the price for the composite, right? And then let's see this. Up to this point over here, we have created cart, which is over here with $200. And also we have created this drive, which is over here $500. And also we have created a bus over here, and also created a chassis over here, and created a cabinet over here. And also for a cabinet, for example, it's a composite, so it's going to point to some list. And indices start with 1, for example, right? So now you can see so far, these components have been created up to now, okay, up to here, okay, up to here. Up to here, there's no connection between any one of them. But now we're going to build a tree, basically, right? Let's see how we can do that. Okay, let me be careful with the color. This line here, we say adding a cart into the bus. So the cart is actually over here. So now the bus is here. The first child should now point to the cart. Okay, hopefully I'm not going too fast. And also, the next one, adding bus to chassis, right? So now for the chassis, which is over here, now the first child that we're going to add would be, want to add that as the bus. Okay, and the second child for the chassis will be a drive. Okay, so now the drive will be over here. So now it's going to be over here. You can see the drive is here. So now it's now going to point to wherever drive is pointing to. You can see we're trying to build the tree bottom up. Okay. Okay, finally, we are also trying to build the cabinets overall. We're saying cabinets, you're gonna contain a chassis, right? So now for the cabinets, for its first child here is now going to point to the chassis. Okay, let's now try to actually trace the code quickly. Okay, so now this single line over here, result is assigned to cabinets.price equals 700, right? So this is the expression we like to trace. It turns out to be quite sophisticated. It seems to be. Let's try to see how we can deal with this. Okay. Let's go from the top. So now let's try this. When you say cabinets.price, let's start with this. Okay. Cabinets dot price. Okay. Apparently, let me ask you this. If I say this is, let me just use a different color here. You can think about the price over here that we're trying to call is called version 1. Okay. And the price that we may call another one alternatively is called version 2. When I try to execute cabinets.price, which version am I going to call? Version 1 or version 2? Okay, for those of you who might be not sure, okay, Joy, you actually said it right. It should be version 2 because dynamic type for cabinets is actually a composite, right? So now the price should be calling version 2. Very good. Okay, good. Thank you. So now let's see this. So now, let me just try to be consistent with my color over here. Okay, so now we know that cabinets, we want to figure out its price. So now we should add up all the children's worth from the cabinets itself, right? So what we will do is we're going to figure out what's the price for this particular cabinets. So now we need to know also, so that means we're going to execute this particular loop. And then how many iterations do we need for this particular cabinets? It depends on its number of children, right? So now this, because there's only one single child, so there's only one iteration, okay? So only one iteration. Okay, for that, okay, now, of course, if you really want to trace faithfully, I'll try to do a little bit more detail with you, but you can also try to do it by yourself, right? In order to trace this, you have to put onto the stack, right? Over here, you can think about this is just the only single iteration that we have, the pink one. Okay, so now when we do that, over here, we're going to see this. Result initially to be 0, and then we'll have over here cursor the item. And then the price. Okay, so now what's the dynamic type in this case? I can give you a little bit hints. Dynamic type over here. So now, okay, guys, let me make this question more precise to you. Okay, we know that when we say cabinets.price, it's now going to go over its list of children. And let's say for the very first iteration, the first and only iteration, right? So now in this case, it's now going to go over its children one by one. Now, my question is, when I call this cursor the item in the very first iteration for the cabinets, what would be its dynamic type? Okay, chassis. Very good. It should be chassis over here. Exactly. Very good. You guys are doing very well. Okay, in that case, that means we're now going to invoke the chassis over here again. Okay, so now that means we're going to invoke the price for chassis. Okay, over here again, let me just do a little bit more because I can leave something as an exercise for you. I can finish that next time. Okay, so now if I try to do chassis dot price, let me just use a different color. So now for chassis, let me use orange, right? So now for chassis, now I'm going to execute the same block of code over here. How many iterations do I need for this particular chassis according to the diagram? 2. Thank you. Because I got 1 and 2 over here, 2 iterations. Very good. And now, one more question before I leave to you as an exercise. Basically, you can see the way we are tracing this iteration here is more like a recursive call. So you really have to see how you can use a stack to trace it. For that, I assume you build a technique from the previous courses. If you got trouble, let me know. Okay, so let me go a little bit further. For the very first iteration now, so now if I got cursor the item over here, and now similar question, what will be the dynamic type for the very first iteration for that? Anybody? Bus. Okay, you guys are doing very well. So now bus over here will be it. Okay, that would be bus. So if you keep tracing this, you will see that which version is going to be called. Basically, every time if you are calling the version that's in the composite equipment, you have to trace exactly which iteration is calling which version. Ultimately, you're going to reach the base case over here, which will be, for example, the price. So eventually you can, let me just summarize quickly. Eventually you can get to the 500 over here and also the 200 here, eventually. And then you're simply going to get 500 plus 200, you get 700. Okay, I'm going to omit the details a little bit since I'm running out of time. Okay, maybe next time I can prepare something to show you overall the structure to save time. Okay, so let me just give you a little bit homework if you want to do some exercise before Monday, if you wish. Optional, but it will be good for your learning. I'm going to post the slides. Maybe I haven't, but I will do. I'm going to post the slides for the visitor pattern over here. That's going to be the focus for Monday's lecture only. And then after Monday, we'll talk about observer from Wednesday. But for Monday, only the visitor. So I would suggest two things. Number one, you can take a look at the slides. Feel free to also go over the alternative design, like a first design attempt, which got some criticism. Read over the design principles. And also, this will be a new design principle we're going to talk about called open-close principle. We're going to see that. And then you will see visitor pattern. Specifically, try to give yourself an exercise. Let's say you haven't really been through my explanation or go detailed walkthrough of the architecture. Can you just look at the diagram here and figure out how exactly or roughly how the design pattern is going to work? Exercise, okay? Go over the slide. It's not many slides, just about 13 slides or less than 10. And then also the tutorial video that I talk about over here about composite and visitor. Okay, so now I'm running out of time, I know. Do you guys have any more last minute questions before I end the sessions? Any questions for you? Okay, let me just see this. Okay, Manesh, okay, let me see this. The composite design pattern seems to be implementing a tree data structure. Yes, indeed. So the composite design pattern is really about building a tree, for sure. You will see that the visitor pattern is about traversing the tree. We'll see that. That's why these two patterns are related to each other so badly. Would a generic tree data structure be able to stand in for the composite? I would say it might be like overkill if you simply maybe you are asking, can you replace the composite design pattern by binary search tree, or maybe by a general B tree, for example? I would say maybe you can try, but I would say it's a composite design pattern just trying to solve a general problem about tree structure. But if you try to reuse part of the code for your general tree, that's fine too. When is the project going to be due? I would say check the course wiki, please. I believe it's the last day for the class, April 6th, I believe. But double check, okay? What about preventing self-cycles in the composite design pattern tree? Let me think about this question here. Okay, Minesh asked a good question, because usually when you're dealing with tree, you don't really want any cycle. But what about for composite design pattern? Okay, let me put it on my iPad notes, and then I will deal with this with some maybe example to show you next Monday. Okay, so the question was, I'm gonna write it down before I forget, right? So the composite design pattern. What if you got self loops? Was like a cycles. Okay, I'll think about it. I'll let you know. Okay, guys, any questions? All right, if no, then thank you for attending. I will see you next time. Okay.